Hello class, this is CSE-4410, sections 1 and 2, um, chapter 3, spring 2024. Alright, so back in last chapter we spent some time building up this scene with walls, floor, basically a dungeon-like area for which the player can explore around, but that's about it. The only really complex thing about this level is the camera controls, which needed some additional considerations for how we rotate the camera around and how the player should move around in the scene while at the same time not cheating. Well, not accidentally cheating. Anyway, if you play through this level for yourself, you'll find that it's a bit boring. There's nothing to do. You can explore all the rooms, but that's about it. So, we are going to fix that in Chapter 3. We are going to add enemies and projectiles. So, the objectives of this chapter, per the Unity textbook, is we're going to write code that enables the player to shoot into the scene, going in guns blazing, basically. We're going to have a target for which the player can hit. We're going to add some code that makes that target wander around, and then we're going to add additional code that automatically spawns this target, and then we're going to add in even more code that enables the target to retaliate. So, with that, let's get into what raycasting is. Because for us to go in guns blazing into the scene, we have to figure out how would a gun in a first-person shooter work. So it's based off of something called raycasting. So I'm going to pull up some slides here. You want to fire a gun in a first-person shooter. How do you do that? How do you do that in code? Well, it's not going to be the gun that fires anything, but rather it's the camera itself. The camera produces what is called a ray. This is going to be a line that starts at the camera, and then it's going to go into the scene itself, and then that ray is going to hit something. What we want to know as a programmer is what did it hit and where did it hit. For this first section of the video, we're going to be more focused on where did it hit. In later code that we add in, we're going to look into what did it hit. So, let's go in guns blazing. Let's go in guns blazing and have the player go in guns. Just have the player go in guns blazing. So we're going to have to become familiar with a few methods here. One of them is screen point to ray, and the other is physics.raycast. For this, we're going to start with creating a new script. So I'm going to say new C# script. I'm going to call it ray shooter. And then I'm going to open that up in Visual Studio because that's what I use. Open. Let me just rearrange some code here. So that and that. Right. First, I need a reference to the camera. So, let me go back up here. What we need to do first is attach this ray shooter script to the camera. So, the camera from last chapter, we had attached that to the player. So, I'm just going to drag and drop the script onto the camera. If I click the camera and look in the inspector, we see that we have a new script attached. So, this is a whole new component. It doesn't do anything yet because, well, look at it, it's empty. But we're going to add in code now. So I'm going to say private capital C camera and then cam. So this is a private field, as it's called. It's a private field that stores a reference to, well, it's going to store a reference to the camera itself. This is attached to the camera, and the camera is its own game object, but attached to it is the camera component. So we need a reference to that, And we get that reference by saying, in the start method, cam equals get component, and then in angle brackets, camera. You are going to want to become friends with the get component method, because by calling get component and then specifying your component type in the angle brackets, you can, for example, tell apart game objects from different game objects based on what components are attached to them. So for example, you have an enemy game object that's wandering around. You're trying to shoot at the enemy. How do you know you shot the enemy? If you do get component enemy, and that method does not return null. If it does return null, it means you did not shoot an enemy. If it does not return null, you can not only know that you shot an enemy, but at the same time, you can also call some code related to the enemy for, say, a death animation, which is what we're actually going to do later. So, next, in the update method, I am going to write in code that does the raycast. However, I need to wrap it like this. If input.get mouse button down, and then I'm gonna say 0. This means if the user presses down, if the user presses down on the left mouse button. If the user presses down on the left mouse button, we're going to do a raycast. So to start with the raycast, I need a point. Vector 3. So I'm gonna say vector 3 point, and the vector 3 is going to be a vector 3 is just a data container with 3 values called x, y, and z. For this vector 3, I need it to have the coordinates of the midpoint of the screen. So I'm gonna say new vector 3. For the x and y values, those are going to be the pixel width and pixel height of the camera. So the camera's looking into the scene, and we need to figure out what is the midpoint of this camera view here. Because that's going to be our origin point. That's going to be our origin for the ray that the camera is going to produce that goes into the scene. Remember, raycasting is where we have the camera produce a ray, it extends into the scene, that ray is going to extend out and hit something. We are going to figure out what did it hit and where did it hit. So I'm going to say cam.pixelWidth. No, not that one. Cam.pixelWidth divided by 2. Cam.pixel height divided by 2. And then 0. Because this needs to be a vector 3, it means it needs to be 3D. And then I'm going to create a ray object. So I'm going to say capital R ray, and then lowercase r ray. And then I'm going to say cam.screen point to ray. And what's the point? Well, it's the point that we just produced earlier. So this is going to be our origin point for the ray that's produced. And how do we know that this ray is going to hit something? Well, thing is, we didn't even do a raycast yet, so we need this. So we're gonna be using this ray in something called a raycast. We didn't even call that method yet, but we need one more thing. It's called raycast hit, and this is going to be a data container that contains information of what did we hit and where did we hit. So I'm gonna say raycast hit, call it hit, and then if I perform a raycast and it hits something, we're gonna do some more code. So let me just fill in this blank here. We do a raycast by calling the method physics.raycast I'm going to pass in the ray, and I'm going to say out hit. So this means if I do a ray cast and it successfully hit something, then this thing here hit. This is going to have information of what we just hit. For now, we're going to say debug.log, and it's just going to print out the hit location on the screen. So hit, colon, and then all that is in quotation marks. I'm going to say plus because it's string concatenation, and then I'm going to add onto that hit.point. That's just the coordinates of what we hit. I save, reload script assemblies, wait for this. And now if I go back to my first person shooter, oh yeah, one thing to do, if you are really far from your main scene, you can just click on any one of these, press you can just double click on one of these and you'll zoom in close to it. Or what you can do is click on one of these, what I'm trying to do is press F, but apparently just double clicking on the objects in here, it'll take you to that game object. So just in case we're really too far away from anything, just double click on the object, just double click on the corresponding object in the hierarchy, and you'll be taken to that object. So now we're at the player. Well, it doesn't matter because we're gonna play the game now. So if I look around, we have the scene as we had before. Nothing much to do, but if I click look in the console, it's reporting coordinates of whatever I'm hitting. So as I said, the camera is, if I click the left mouse button, the camera is going to cast a ray into the scene, and if it successfully hits something. So if I aim at the sky, nothing's gonna happen because there's no game objects up here. But I can aim at the wall, and I get the coordinates of where I hit the wall. There's one little confusing thing about this, and it's this. You would think that it's the cursor, that is the location of where you're hitting, but it turns out no. It's actually the middle of the screen. So if you want your ray casts to work at the location of the cursor, then this isn't gonna work. You would need to figure out, you have to translate coordinates of the cursor into something that our raycast code can understand. But for our purposes here, it's something like mouse location to screen coordinates. And then you'd have to pass that point in as your origin. But for our purposes here, as is common with a lot of first-person shooters, it's the middle of the screen from which your projectiles originate. So it's not obvious that... So right now it's not obvious that it's the middle of the screen from which that we are actually producing our ray. So later on, we're actually going to hide the cursor, and then we're going to add crosshairs into the middle of the screen. There's several ways to do this, but one of them uses a ongoing method that we'll look at a little bit later. For now, yeah, it's telling us where did we hit in the console, but wouldn't it be nice if we had a visual indicator in-game for that? Like bullet holes, or maybe burn marks. Anything that we can just place in the game world. Well, the chapter here explains what we're going to do. What we're doing is a little bit different. We're just placing down we're going to place down spheres in the game world. So everywhere we shoot, it's going to place down a sphere. It would sound like that's going to fill up with spheres in no time at all, especially if you spam the mouse. But we have a way of doing this so that it doesn't spam, so it doesn't overload the game world with a lot of objects, and that is, we're going to place down a sphere at the exact location where our raycast hit, and then we're going to wait some time, and then we're going to destroy that sphere. That's gonna use something called a coroutine, which I'll get into now because this is the next step of what we're going to code. So, the ray shooter script here is producing a ray. So if it successfully hits something, right now it's going to say debug.log, and then it's going to say where did it hit. Let's do something else. We're going to call what's called a coroutine. And a coroutine is going to be, a coroutine is a special function. It's a special method of return type IEnumerator. So this is going to be a private coroutine because only the ray shooter script is allowed to call this. So I'm going to say private IEnumerator sphere indicator, and as a parameter we're going to take in a vector tree that is coordinates, and those coordinates is for the location for which we spawn a sphere. Vector 3 position, not point of sale or the other POS. I'm going to create a new game object called sphere equals name object dot create primitive type dot sphere. I'm going to then say, so now we have a sphere. It's a game object like any other game object. So I can say sphere dot transform dot position, and then I can assign it this position value here. So I'm gonna copy that, paste it here. So now we have a sphere. It's at the location of this parameter. And then I'm going to wait 1 second, and then I'm going to destroy it. So here's how it works. I'm going to say yield return new, wait for seconds, and I'm going to say 1. So we're going to wait 1 second, and then after that we're going to destroy the sphere. Destroy sphere. Okay, so now we have this method that's going to spawn a sphere at a specific location. I have an extra parenthesis I have to get rid of. There we are. So now we have this method where it's going to spawn a sphere at a specific location, and then after 1 second, that sphere is going to disappear. So now I can copy this, comment out this line, and then add this line here. So instead of saying, so now we can just copy hit.point. So what does this do now? It means if the player presses down on the left mouse button, we're going to perform a raycast. If we end up hitting something, then we're going to spawn a sphere at the location that we hit. That sphere is going to stay there for 1 second and then disappear. So what does that look like? So I'm going to minimize that. I'm going to minimize Visual Studio and go back into Unity so we can see what it looks like. So if I just click, nothing's happening. Did I save it yet? Hold on. Okay, you want to know what the problem was? We can't say sphere indicator hit.point. We can't say sphere indicator with an argument of hit.point. that's not how we start coroutines. We need a special method for that, and it's called start coroutine. And then I pass into that the entire invocation of the method here. So I invoke the method by calling start coroutine. One other interesting thing that I wanted to talk about is we can actually store a reference of our current coroutine. So if we have, for example, private, and the data type is coroutine, and I'm gonna say current coroutine, what I can do is copy paste this variable name here, and I can say current coroutine equals start coroutine. So start coroutine actually returns a reference to the coroutine that's being run. So if we wanted to, we could, because this coroutine is going to run kind of sort of in the background of whatever our player is doing. And that coroutine is going to do the spawn a sphere, wait a second, and destroy the sphere. So what happens here is we could have extra code that limits us to placing one sphere at a time. Well, there's several ways to do this, but the textbook has a specific way that is shown. But if you can imagine having different coroutines for shooting down different shapes, by saving a reference to the current coroutine, you could limit yourself to placing down one shape at a time. Well, we're not gonna do that here, but that is something interesting that I want to bring up. If you ever want to, for example, limit your character to doing one specific action at a time, because you can have your characters or your enemies perform specific actions using coroutines. This is what coroutines are often used for. If you want to keep your objects to doing one thing at a time, you would save a reference to the coroutine. And then you would say something like this: if the current coroutine is null, then we are allowed to call a new coroutine. If it is not null, then don't do anything yet. Don't do anything until that already running coroutine has finished running. For now, we're just using coroutines to just place down spheres all over the place. And this is what it looks like. So start coroutine is the method that we use to call coroutines. So now if I click here, sphere, 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 lots of spheres. And they all disappear, and they all disappear after 1 second. Now we have a way of figuring out where we just hit. If you feel like that sphere is a little too big, then one extra thing that would be worth doing is going into code and saying something like this: sphere dot transform dot scale equals, I'm going to say vector 3.1. So this is going to be a vector tree whose x, y, and z components are all 1. I'm going to multiply that by, say, 0.1f. So this is basically scalar vector multiplication. If I say vector 3.1 times 0.1f, that's basically the same thing if I just said new vector tree and the x, y, and z components are all 0.1, 0.1, and 0.1. Either way works. Either one will work. So this is just to shrink down the spheres so they are not as large. Now if I play this, same thing as before, except the spheres are smaller. And then I can try to step on them. It's like a snowball fight. now we have the player placing down spheres wherever they click. Okay, but what about the crosshairs? As I said, it was a little bit problematic seeing the cursor in the screen and not seeing spheres being placed down where the cursor is. So we're gonna fix that by hiding the cursor, and then we're gonna replace the cursor with some crosshairs. So, some more code to add into the start method. I'm going to say cursor dot lock state equals cursor lock mode dot lock. What that's going to do is it's going to lock the cursor to the game screen itself. And then I'm going to say cursor dot visible equals false. So that's just gonna hide the cursor. So what happens now if I run this? Oh, we're not done yet. We're not quite done yet. But I want to demo this anyway. So what this does is it's going to hide the cursor. It's going to lock the cursor to the game view. So now the cursor's gone. Well, we'd still like crosshairs on the screen, and how am I supposed to get out? I'm stuck. Well, yeah, you are stuck, but that's because we locked the cursor to the game view, and if you want to escape, press escape. All you gotta do is press escape, and the cursor's back, and now we can just close the game. Let's work on those crosshairs now. So we're going to need another method called onGUI. It's private void onGUI, and I'm gonna say int size equals 12. That's going to be the size of my crosshairs. I'm going to calculate the coordinates for which we're going to draw our crosshairs. So float pos x equals cam.pixel height divided by 2 minus size divided by 4. I'm going to say float pos y equals cam. Oh, this should be pixel width. And the other one should be cam.pixel height. That's divided by 2. And then I'm going to say subtract size divided by 2. And then I'm going to say GUI.label. I'm going to pass in a new rectangle, so it's new rect, and it's going to have pos x, pos y, size. So this is basically the size of our label, and our label is going to be literally just an asterisk. So we can use this symbol as our crosshairs, and if we play the game now, what do we see? Well, it's really hard to see, but maybe it's because my screen resolution is so high. It's a 4K monitor that I do all my recordings on. But if you just look really closely, maybe you have to adjust the resolution of the video on YouTube. If you just look really closely, you'll see a little bright dot. That's our crosshairs. That is where our spheres are going to. So it's really small. There are other ways of producing a set of crosshairs. One way is to use what's called a canvas, and then we can just have a sprite element on the screen, or even more text. We can have a text object on the canvas placed in the exact middle of the screen, and we can use that as crosshairs as well. That works too. It's a set that's going into UI design or a video game, which we haven't even gotten to just yet. For now, at least we have crosshairs, and now I have a chain of spheres going at me. It's getting closer and closer and closer, and then it hit me. So now we can just shoot things shoot spheres all over the place in our game. But what if we had a specific target for which we can aim at? So here's what I'm gonna do. So we have this whole game to ourselves, and we have this cube from before. If I double click on the cube in the hierarchy, I'm going to move the scene. I'm going to move to that object in the scene view. But I want to go back to the player, and I want to give the player a friend. Or no, I'm gonna give the player an enemy. So I'm going to right click in hierarchy, 3D object, cube. I'm gonna call it enemy. Insert Imagine Dragons reference here. Hold on. Alright. So I need to get this on the screen. Well, on my side screen, because I have all my instructions on the side screen. Just the location of this cube. Let's have it a little bit closer to the floor. I want to stretch it along the y-axis so it's a little bit taller. That looks good. Say 1.8. That's good, right? Something like that, so we have a cube. We're gonna do target practice on this thing. Next, I want a new script. I'm gonna call this, I'm gonna create a new script. Call it reactive target. And then I'm going to attach this script. Reload script assemblies. Hold on. Drag and drop the reactive target script onto the cube. So if I click on the cube now, and look in the inspector, there it is. We have the reactive target script. Now, before we even write anything in that script, what I'm going to do now is I'm going to go back to our raycasting code, and then I'm going to make a few changes. Really, I'm going to make changes in here. So we're going to say place a sphere down if we hit anything that isn't the enemy. Or rather, back up. I'm going to say now, if I do a raycast and it hits something, if that something was the enemy, I am going to say we hit a target. Otherwise, if what we hit was not the enemy, we're just going to place a sphere down as we did previously. So, I'm going to need to erase this debug.log, and instead, I'm going to need to get a reference to the game object that we had hit. So, game object hit object equals hit.transform that game object. So this hit, it contains information of not only where we hit, but what we hit. And remember what I said about the get component method? I can say reactive target and then target equals hit object equals hit object dot get component, and then in curly brackets I can say reactive target. So now if my raycast hits something, I can tell whether or not what I hit was the enemy. And if it was, then this target will not be null. Because if it was a target, this get component method is going to return something. It's going to return something that isn't null. It's going to return a reference to the target's reactive target component. So I'm going to say if target does not equal null, then I'm just going to print target hit. So debug.log target hit, else copy paste this start coroutine line. Go back. Nope. And there we go. And this is before you write. This is before writing anything in that reactive target script. So, let's try this out. If I run the game now, and I try to hit the enemy, target hit. I have to press escape because the cursor is now locked to the game view. But if I do that and I click on console, there it is. We have successfully hit a target. We can tell apart the target from things that don't have that reactive target script. So, I can hit the enemy all I want, but nothing happens. We want the enemy to do something upon being hit. Maybe we want the enemy to retaliate, or maybe we want to do a death animation. The next step, we're going to do a death animation for the enemy, and for now, I'm going to pause the game. So, we can now hit the enemy all we want. We can hit it all day, but nothing special is going to happen. Now, let's go back to our code. Instead of saying debug.log, I'm going to comment out that line, and I'm instead going to say target.react to hit. Now, this method does not exist. I put that there because we're going to create a method for that. The reactive target script does not have a react to hit method, but that is going to be the next thing that we write. Reactive target does not contain a definition for react to hit, and no accessible extension method react to hit accepting a first argument of type reactive target could be found. Are you missing a using directive or assembly reference? So that is the current error that we have, but really it's because we didn't even write that method yet. So open reactive target script. We're going to literally add in as the first thing that reactive target method, that reactive target react to hit method. So public void react to hit, no parameters, and we're just gonna say start coroutine die. Okay, but now we have this die method here, but we have to write that next. So you can probably tell that this is going to be a coroutine. So it's a coroutine for the enemy's death animation. So I'm going to say public I enumerator, not I enumerable, public I enumerator die, and the death animation is going to be like this. I'm going to say transform dot rotate minus 75 0 0. So the enemy is going to fall back over. And then I'm going to say yield return new, wait for seconds, 1.5f. So the enemy is going to fall back, and then we're going to wait 1.5 seconds. For what? For this. Destroy game object. So this is lowercase game object compared to capital G game object. Lowercase g game object is actually this dot game object. So it's the game object for which the reactive target script is attached to. Capital G game object, you can think of that as a data type. And if you type in capital G game object, it's going to be the same color as the reactive target class name here. It's also going to be the same color as mono behavior here. Anyway, what this means now is if we hit the target, it's going to die. You want to see? Alright, reload script assemblies. We should see that error go away soon. And now we can play, because if we have any errors, the game's not going to work. Hit There we go. Okay, so now the enemy's gone. Alright. So the enemy now falls over if it's hit. Alright. Okay, but now we want the enemy to do a little bit more than just fall over and die. We want the enemy to just move around. And then if it's hit, we want it to fall over, perform its death animation, and then die. Alright, so this gets into the next section of the chapter, and that is we're going to program AI. We're going to program an AI for our target. The enemy's just standing around. It's boring. We want the enemy to do something. So here's what we want it to do. We want this enemy target to move forward. We're gonna have it detect obstacles. And if it detects an obstacle that's too close to it, it's going to turn around and then repeat the process. It's going to move forward, detect obstacles, turn away, and repeat. Every frame. We're gonna do this every frame. So here's some slides that illustrate what we're gonna do. So if I can hide away my camera, because otherwise I can't really show all of this. We want the enemy to move forward. We want to detect obstacles. We want to turn away from obstacles and repeat. We do this obstacle detection using the same thing that we did for how the player is able to figure out where to hit, where to place spheres, and all that. We're going to do another raycast. There's one caveat, however, and it is this. So as I said, every frame we want the AI character to do a raycast to look for obstacles. But we can't do that with just an ordinary... We can't do that with the same kind of raycast as we did before, because if we did that, that is an infinitely thin line. A ray in geometry is an infinitely thin line. It has no thickness. So what if if we did that raycast, it's possible that it's going to miss some obstacle that's even closer to it. So we want our ray to have a thickness to it. We would like that raycast. We want that ray to be as thick as the enemy is wide. So in Unity, there is another method similar to raycast, but it's called spherecast. So basically, we're doing a raycast, but there is thickness to the ray that we are creating. So we're going to create a new script, another script, called Wandering AI, and we're gonna code all of this. We're gonna code in this spherecast. So I'm going to create a whole new script. Create C# script. Walk. No, not that one. Let's try it again. Create new C# script. Wandering AI. Reload script assemblies. Come on. Wait. Hold on. Open the script. Now, we're going to add in some more code here. So, let me just get this started. First, I'm going to add in a few fields. Public float speed equals 3.0f. That's how fast this is going to be how fast our enemy is going to move. We're going to add in public float obstacle range equals 5.0f. That's how close obstacles should be for our enemy to detect. How close should these obstacles be before the enemy needs to turn away? In the update method, so I'm not going to need this start method yet. I'm just going to go straight to the update method. I'm going to do this process that we talked about step by step. First, I'm going to do transform.translate 0, 0 speed times time.delta time. So remember, time.delta time is how much time it was from the last frame to the current frame. This is going to be a small amount of time that we multiply by our speed. Speed times time, well, technically it's going to be velocity times time, but in our case, it's going to be speed times time. Speed times time equals distance. So this is going to be how much are we going to move forward in one frame. And then I'm going to do all the same ray casting code as we did that the player had. So I'm going to say ray, capital R ray, lowercase r ray, equals new ray transform dot position as our origin point, and then I'm going to say transform dot forward for which way our. So we are using the enemy's current position as the starting point, but you also need to tell it which way is that beam going, and it's going to go forward. So I'm going to say transform dot forward. So one thing you need to know about axes on game objects, the positive z axis, that is the forward direction. Okay, so if I hover over this, it's going to say return a normalized vector representing the blue axis of the transform in the world space. So remember how axes are color-coded in Unity? Red is x-axis, green is y-axis, blue is z-axis. So whatever direction the game object's local z-axis is pointing, that is the forward direction. So this ray is gonna need two things being passed into it. It's the origin point of our ray and which way it's going. Next, I'm going to say ray cast hit. So this is our data container containing the information of what we hit, where did we hit, and what. I'm going to say if physics.spherecast. And this requires 3 arguments. The first argument is the ray itself. The second argument is a radius. I'm just going to say 0.75f. And the third thing is going to be out hit. So if I do out hit, what actually happens is, you know how some functions in, say, C++, for example, you can pass them into a function and they'll have stuff added to them. Say, if you perform a swap function, if you call a swap function and you pass in 2 variables and their values are swapped, it's like that, where you have whatever's coming in being modified. In our case, we are passing in hit, and it's going to contain all the information of what we hit and where we hit. So that's what's going on here. We need to then say if hit.distance. So it turns out hit also has distance from what we hit. If hit.distance is less than obstacle range, then we're going to do float angle equals random.range, and then this is going to be a random angle value from negative 110 degrees to positive 110 degrees. So I'm gonna say negative 110, positive 110, and then I'm going to say transform dot rotate. We are not rotating about the x-axis. We're not rotating about the z-axis. We're rotating about the y-axis. So 0, angle 0. So now, this wandering AI script will tell our enemy cube to move around, detect obstacles, turn away, repeat. So now I close this, and I need to attach this script to wandering AI script is to be attached to our enemy. So if I click on the enemy, we have now 2 scripts attached. The first one was the reactive target script. That is the one with the death animation and all. Now we have a wandering AI script. So if I play, this enemy cube should now move around. And he's gone. Wait, come back. So if I zoom out and see what's going on, the enemy's just spinning around in place. That's because we made his obstacle range a little bit too high, but that's the thing about Unity, we can change these values in the inspector. Just not while the game is running. So we can just decrease this obstacle range to say 2.5. Yeah, so let's say 2.5, so that way the enemy has a bit more tolerance for where... Hey, come back! There we go. So now our enemy is just wandering around. Dip, dip, moving, they're close, up, rotate, and too close, wandering around, nope, rip. So now this enemy is just wandering around. Oh yeah, its sense of its forward direction is going to be changing a lot because it's rotating. If it rotates, its forward direction also rotates along with it. So I said something about the blue arrow being the forward direction. Not necessarily the case if the object is going to be rotating like this. So, let's go back to the game view and try to hunt down this object. So now this object's just ping-ponging around the scene, moving around in that one room, if I can get to it. Let's see what happens if I... Oh! So, it got hit and then just floated up into the sky. Well, we gotta fix that. So, let's escape and talk about a concept called a finite state machine. In computer science, there is a concept called a finite state machine. So this is an abstract machine whose operation is determined by a set of states. So this machine is going to be in one of several states. It also has what's called a transition function that says how you move from one state to another. So a finite state machine can get pretty complex. We can have multiple states for a thing, and that thing can perform lots of different actions. For our purposes in game programming, we can use the concept of a finite state machine to restrict certain actions on our game objects. Say an enemy might be wandering around, it could be standing still, it can have an idle animation, for example. It could just be idle, and then when the game starts, it enters a wandering state. So it's just wandering around, and if it sees the player, it's going to enter an aggressive state, for example. So now the enemy could, for example, attack the player, and if the player attacks back hard enough, the enemy could die. So it enters a death state where it can't do anything else. it turns out this is what we want for our enemy cube here. It's just that we only really need two states. So it's a two-state machine where in the first state it's allowed to move, and it's in the second state it's dead. So let's go back to our wandering AI script. We're going to go in here, and we're gonna add a private bool is alive. So it's only really two states, so it's a binary system of alive and dead. So we can just use a single Boolean value to determine our state. So private bool is alive. In the start method, we set this to true. Is alive equals true. So what we do next is, it's only gonna be allowed to move if it's alive. So the problem is, when it died, it was still moving forward. So we want to disallow that moving forward. We only want to move forward if it's alive. So I'm gonna say if is alive, and then I'm gonna surround this transform.translate method in curly brackets, so that way it's only gonna be, this line's only ever gonna execute if is alive is evaluating to true. So now, if we try to hit the enemy now, let's go back and run this game again. There you are. I can still shoot as I was before. It's just that now if I shoot the enemy, it's still not working. It turns out we're missing a few things. So, what are we missing? Well, we're actually missing another method. It's this. Public void set alive bool alive. So this is going to be a public method that any other script can call, and it's going to set this enemy cube to be either alive or dead. So I'm going to say is alive equals alive. And that is the parameter here. So if false is passed in, now it's dead. So now we have this method. So this is all in the wandering AI script. So where are we gonna be calling this set alive method anyway? Well, it turns out we're gonna be calling it in the reactive target script. So we have this script here. In the react to hit method, well, let's go back to the enemy target first. It has both a wandering AI script that is now a two-state machine where it's going to be either alive or dead, and it can't move if it's dead. We also have this reactive target script where it's going to perform a death animation if it gets hit. So both scripts are on the enemy object. It's just that one object needs a reference to the other. The reactive target script needs to know that wandering AI exists. And if it does exist, it needs to then call this set alive method so that if it gets hit, it's going to set the wandering AI script to a death state. So here's what that looks like. Wandering AI behavior equals get component wandering AI in angle brackets, and then Then we're gonna say if behavior does not equal null, I'm going to say behavior dot set alive, and in parentheses, false. And then we're going to say start coroutine die. So the reactive target script is its own behavior, as is the wandering AI script. Reactive target, all it cares about is, am I dead? If I'm dead, I'm going to perform this death animation. Wandering AI is concerned about, am I allowed to move? Am I allowed to move? And if I'm moving, is there an obstacle in my way? So if reactive target, if the enemy gets hit, it's going to basically tell wandering AI, you're dead now. Don't move anymore. Meanwhile, reactive target is going to say, I'm dead now. I'm going to perform my death animation. So that's what's happening here. So now, if we run this game, we're adding quite a lot to this game now. So okay, so now we have this cube wandering around. It sees me, and it's avoiding me because it thinks I'm an obstacle. I'm gonna hit it. Well, there is one slight issue here, and maybe this is something worth programming in as well. If it's dead, it shouldn't rotate any more than once. So, yeah, so that's one issue that we might need to come back and circle around to, or maybe we can just leave it in for the sake of being funny. But anyway, the point is, now, if you hit the cube, it's gonna stop moving, it's gonna rotate, and then it's going to disappear. And that's its death animation. It's going to instantaneously rotate. We wait 1.5 seconds, and the enemy is gonna destroy itself. And that is its death animation. So no longer is it going to move unless it's alive. If it's dead, it stops moving. So now we have this fully fleshed out enemy in our game. I'm going to drag and drop it from the hierarchy into the project view. What did that do? Well, it turned it into what's called a prefab. So it's going to be just like any other asset in our project here. So now, what I can do now is I can delete it from the scene, but I still have a copy of it here. If I need another copy of the enemy, I can just drag and drop, drag and drop, drag and drop. I can drag out and drop all of these as I need to. Because it's now a prefab, I can make as many copies of it as I want now. So, as a little bit of fun, first of all, I need to make sure they're all not too far from. I need to make sure they're not too far into the ground. But after that, if I press play, you should be able to see a bunch of cubes just avoiding each other because they're seeing each other as obstacles. However, we have a few cubes that just noped out of the entire scene because they must have clipped through a wall. And now they're just wandering forward forever, never to be seen again. This could be a bug. If this is to be a game where the end goal is to shoot down a specific number of enemies, then we failed. So we may need to have extra code to make sure that these things, if they go too far, they get destroyed and new ones are placed back in their place. Hey, how are we supposed to spawn these things now? if, say, we have code that says destroy this game object and put it back, how do we respawn it? Well, that's our next step now. And that's another thing about this scene here. We could copy-paste this enemy a bunch of times, or we can let the game do it for us. So I'm going to delete all of those, because if I delete them, they're merely instances of this enemy prefab. So it doesn't matter if I delete them from the scene, as long as I still have it in the assets folder. One other thing, it might be worthwhile to organize your prefabs folder. No, it might be worthwhile to have a folder for all your different things that you're gonna be adding in your game. So you might have a separate folder for prefabs, separate folders for scripts, separate folders for 3D models, separate folders for what are called materials. That's gonna be one of our next things. So a material is going to tell, say, a game object what color it should be, but it also might also be how shiny it is, how reflective it is, how glowy it is, what kind of texture it should have, because it's not necessarily a monochromatic texture that we can apply. So, once again, that's going to be one of our next things. But for now, as I said, we could spawn this enemy multiple times by just copy-pasting it from the assets folder into the scene. Or we can write code that does it all for us. So, one other thing to make sure about this enemy prefab, I'm gonna make sure I set its Y to 0, so hopefully it doesn't... What I'm trying to do is edit the prefab itself, so I have to click on this, and maybe if I can... No. Never mind. So, one thing you'll notice is if I try to drag and drop copies of this enemy cube, they're sunken into the floor. So the script that's going to spawn all of these at once, it has to raise them off the ground a little bit. So we're going to work on that as well. So I'm going to delete. We are not going to spawn them by just dragging and dropping them from the project view. We're going to write code that does it for us. So how do we do that? First, I'm going to make a whole new game object. It's going to be an empty game object. Create empty. I'm going to call it controller. So this is going to be a scene controller, and it's going to place down an enemy object if there isn't one. I'm going to create another script, and I'm going to call that scene controller. Open that script, and now we have a scene controller script. What it's going to do is, as I said, it's going to place down game objects if they don't exist. Specifically, it's going to place down the enemy game object. So now we're going to write down some more code that looks like this. Let me just get these curly brackets in the way. One thing that I would highly recommend you do is to look at a style guide for C#. Find a style guide that you like and follow it religiously, so that way you know how to write your code in a way that is consistent. I personally have opening curly brackets on the same line like this, so I say public class, class name, and then open curly bracket. Some style guides might have this instead, which is the default for this automatically generated script. Just whatever style guide you adopt for yourself, be consistent. This also goes into how you name your private and public fields. So it's not well demonstrated here, but one common convention is to prefix an underscore to every private field that you create. So something like this. So you can look at that and say to yourself, oh, that is a private field. Okay, so now we have a private field. I'm just gonna I'm gonna remove that underscore for programming purposes. But now I have a private field for the current enemy that's being spawned. Hey, how does this thing know what to spawn? Well, I have to assign it that. But here's the thing. I don't want any other script to change what this game object is going to be spawning. So the scene controller is the only thing allowed to know what enemy prefab to spawn. So how are we supposed to... Here's the other thing about private fields. They don't show up in the inspector. So how are we able, if we want the scene controller to have a private variable, if you want the scene controller to have a private field for what kind of prefab to spawn, and it being private, we cannot have any other script change that. How are we supposed to have it show in the inspector? By adding an extra tag called serialized field. So it looks like this. Serialized field, game, object, enemy prefab. So this is going to be... What this does is it opens up that private field in the inspector. So we as programmers can still edit it in the inspector, while at the same time disallowing all other scripts from ever editing that field. So now let's spawn an enemy. If enemy, so it's this enemy, is null, that means there's no enemies yet. So we're gonna instantiate one. Enemy equals, I'm gonna call something called instantiate. Instantiate enemy prefab as capital G game object. Depending on your code editor, it might say that this is unnecessary. Cast as redundant, it might say. Or it will say if you're using Visual Studio, which I am. Then I'm going to say enemy.transform.position equals new vector 3 0, 1, 0. So this is going to be the spawn coordinates for our enemy. I'm going to give it a random rotation, so I'm going to say float angle equals random dot range, and I'm going to give it a random angle from 0 to 360 degrees. So 0, 3, 6, 0. A lot of games feature random numbers, so maybe you'll want to get acquainted to the random.range method as well. And then I'm going to say enemy.transform.capital R rotate. And then I'm going to pass in Euler angles in the form of 3 separate values. So it's 0, angle, 0. So now we have this spawner. So the scene controller is in charge of spawning enemies if there isn't any. But it's programmed in such a way that there can only ever be one enemy at a time. If we wanted this game to be a bit more difficult, we would want to have it so that it spawns multiple enemies at a time, and it keeps track of how many enemies are already on the level. So maybe that's an exercise for you. I'm gonna leave that as an exercise to the reader then. For now, let's roll with this. So this scene controller script goes on to the controller game object. What I'm going to do is set its position back to 000 to make sure nothing weird happens. Then I'm going to take the scene controller script, drag and drop it onto the controller in the hierarchy. So now we have a scene controller script. We have enemy prefab, none. So there's no game object. It doesn't know what to spawn yet. If I play it, it's going to say, null reference error or something. Yeah, there. Unassigned reference exception, the variable enemy prefab of scene controller has not been assigned. So we have to fix that by simply, we have an enemy prefab already. All we gotta do is drag and drop that from the project view into this slot in the inspector. So now I play that. If I play that, whoop, where'd it go? I saw a cube just pop out, and now we have this cube just spazzing around in the next room over here. So if I go to that room and say hi to this cube, if I can find out how to get to that room, it's probably over here. Hello. I can shoot it. It dies. And now if I go back to the original room, well, it might be hard to find again, but if I just press escape and go to the scene view, we have a cube. Another one. So now, this game can now spawn new objects as needed. Okay, but maybe the objects are spawning a little bit way too high for us to conveniently see. I'm gonna go fix that up, but let's see how high up it is. If I just go into here, no. Maybe if I just cheat and just move the player to the same room. If I press game. Okay, so our enemy is a little bit high up, maybe a little bit higher than it needs to be. I shoot, it dies. So where's this new enemy now? Okay, same room as before. So if I pause this and click on the enemy, the problem is it's spawning a little bit way too high. So if I adjust its position from being 1 for the Y value, and I make it a little bit lower, say 0, then maybe that's gonna be enough for, maybe that's enough, maybe that's a better position for our enemy. So I'm going to pause this, and I'm going to edit some code in here. So instead of 010, I'm gonna say 000 as the spawn location for our enemies. And then I want to edit this. So maybe instead of an obstacle range of 2.5, it's gonna be 1. That way, it's a lot more tolerant of closed spaces. Basically, it's allowed to get much even closer to obstacles in its way. So if I press play, where's the enemy? Oh, it spawned over here. So I'm gonna go back to game view, and there he is. I'm gonna hit it. Okay, so I managed to hit it. And where's the new cube now? Probably in the next room. So you might want to adjust the walls of your... It might be worthwhile to adjust the walls in your level to make sure that there's enough room for your enemy cubes to spawn. And now it's dead. Now if I go back into the same room as before, and you look here, new cube, shoot it down, it dies. And a new one just spawned, and it just phased through the wall. So I might have to go back into the next room over and make sure it's dead. One other addition worth doing is having specific spawn locations. So you can write in code specific spawn locations for your cubes. Your scene controller could randomly pick out one of those possible spawn locations, spawn a cube at that location, and then you'd have to hunt down that cube. So now our game is shaping up to be a bit more exciting than just wandering around this space and having nothing to do. Though there is potential for spawn camping, that is something we may need to... that's something that I'm just also gonna leave as an exercise to the viewer. And you're dead. And you're dead again. And you just face through the wall. Now we have these enemy cubes just being spawned. Let's do one more fun thing. So now we have this scene controller that can spawn new enemies as needed. The last thing that I would like to get to is having these enemies shoot fireballs at the player. Let's do it! Now, this video is going to be nearly 2 hours long, but really that's because there's just quite a lot of concepts to get through. So, okay, so now I'm going to create a brand new game object. It's a sphere. That is way too low for me to edit, so I'm going to reset its coordinates and put it over here. Speaking of which, I think I'm just gonna have to move the player a little bit out of the way, and maybe this wall out of the way, so that way there is sufficient room for the enemy to spawn and then just wander around. So, with those changes in mind, let's turn the sphere into something that the enemy can fire at the player. So now we have this sphere. Let's call it Fireball. I'm going to create what's called a material. So if I right-click in the empty space in the Assets folder here, Project View, here, Create. It's a little bit further down, so it might be hard to see. So, it's going to be here, Create, Material. I'm going to call this Flame. So it looks like a sphere, but the icon for materials is always a sphere. So don't get this sphere confused with this sphere, because we're going to turn this into a prefab. For now, I want to edit this sphere. No, I want to edit the material. So I'm going to make it look like a fireball. The first thing I can do is I can change the color here to something that looks more like fire. So maybe make it a really dull. Make it choose a color that looks like fire. So maybe something like this. So that's one thing we can do. And if I want to put this material on our fireball, it's also drag and drop. So I just take the flame material and I place it on top of... You can see a preview of what this material looks like right before you drag and drop it onto your game object. So I can place it on the floor, and now the floor is lava. But I don't want it to be lava just yet. I want this to be lava. So, I don't know, does that look like lava to you? Maybe not quite, but we can make one extra change, and that is, see this little checkbox called emission? I can make it glow an extra color, so with that, I can pick out, say, something like this, and it's going to make the object glow. Basically, that's what emission is in a material. It makes an object glow. So now we have this object, and now it looks like a heated metal ball. Maybe that looks more like lava though. So if I play the game now, I have this ball of fire that does nothing to me, and also it's just floating here. But it's glowing. I can shoot down the enemy cube, and the enemy cube avoids it like it's just another obstacle, because we did not add any other code to this fireball yet. So I'm going to exit out of here. We're gonna need to do a couple of things. What we're gonna do now is I am gonna turn this into a prefab. So this fireball, it's prefab time. So drag it from the hierarchy into the project view. Now we have a fireball prefab next to our enemy prefab. So these two are prefabs. This is a material. So now I can just delete this fireball from the scene, because I have another copy already here. Alright, so let's go back to our wandering AI script, and we're going to add in code that is going to shoot a fireball at the player. So we need a few extra fields now. I'm going to say serialize field, because I want to be able to set this in the inspector, and I don't want any other scripts to touch it. Game object fireball prefab. And then I'm going to say private game object fireball. So now I have what I'm going to have is a reference to the prefab I'm going to spawn, and then I'll have a reference to the current fireball that has been shot out of the enemy. Excuse me. So you know how the player was able to shoot spheres onto the player is able to shoot, and through that shooting code it's able to place down spheres where it was shooting. The player was able to detect whether it was shooting an enemy as well. So what we want now is to have the wandering AI code to determine whether the object in front of it is the player. So here's what we do now. I'm going to create another script called player character, and I'm going to attach this. Oh, no, it's that. I'm going to attach this player character script onto the player. That way, if the enemy, while it's doing its sphere cast, determines that it's looking at the player, it's gonna fire a fireball at the player. Alright, so now we open up that wandering AI script again. So, we're going to modify this code in here a lot more. So I'm going to say if physics.spherecast ray 0.75f out hit, if I hit something, I'm going to see whether I had hit the player character. So I'm going to say game object hit object equals hit dot transform dot lowercase g game object. And then I'm going to say this: if hit object dot get component, and then in angle brackets player character, I'm gonna say basically what this says: if the object that was in front of me has the player character script, then that is the player. I'm going to shoot a fireball at it. If there is no fireball already spawned, if fireball is null, then I'm going to create a fireball. Fireball equals instantiate fireball prefab as game object, and the as game object might be unnecessary. I'm going to say fireball dot transform dot position equals transform, not transform, transform dot capital T transform, and then capital P point, and then I'm gonna say vector3 dot forward times 1.5f. So this is going to spawn a fireball in front of the enemy. And then I'm gonna say fireball dot transform dot rotation equals transform dot rotation. So what this does is the enemy is going to be angled in some direction. The fireball is going to be angled the same way. So what happens is the fireball is gonna be spawned and it's going to move forward in the same direction as the enemy. So now this wandering AI is now able to spawn its own fireballs, and they're gonna hit the player. One last thing, it's this. So now what this whole block of code says now is this: if I perform a sphere cast and it hits something, if it had hit the player, spawn a fireball and have it move forward in the same direction that I am towards the player. Otherwise, I'm gonna treat that as any other obstacle, and I'm going to move out of the way by rotating. So that is what that code says. Let's try it out. So the wandering AI script now requires that we have a reference to our fireball. And remember that the wandering AI script is attached to the enemy, and we have the enemy as a prefab. So we need to take this fireball prefab from the assets folder, drag and drop that to, in the inspector view, we have the enemy prefab opened, drag and drop the fireball from the project view into this slot here. So now we can now spawn an enemy. No, we can have the enemy spawn a fireball. How? What do you think would happen if I had mistakenly took the enemy and put it here? Think about what would happen. Basically, the enemy would spawn itself, and then that enemy would spawn itself. And we might have out of control growth. We might have out of control spawning of enemy objects, which might just crash the game depending on how fast these enemies are spawned. But let's just put this here. So now we have a fireball. Let's get in front of the enemy cube and see if it'll hit us. Well, it kind of did, but the problem is we never added code that made the fireball move forward. So we need to fix that. It's just gonna spawn a sphere, but then that sphere's not gonna do anything. It's just gonna be stuck there. So we're gonna need another script. I'm gonna say its name is Fireball. So now I have a Fireball script in addition to a Fireball prefab. I'm gonna open up the Fireball. I'm gonna click on the Fireball in the project view so it's open in the inspector. I'm going to drag and drop the Fireball script from the project view onto the into the Fireball as it appears in the inspector. So now we have a Fireball script attached to the Fireball prefab. Let's edit the Fireball script. Let's just move a few things out of the way. So that and that, adjust that. I'm gonna have a few public fields. One of them is public float speed equals 10f. So this is how fast the fireball's gonna move. And then I'm gonna say public int damage equals 1. So it's going to deal 1 point of damage. In the update method, I am going to say transform dot capital T translate, and then I'm gonna say 0, 0 speed times time dot delta time. Because remember, speed times time equals distance. So if we're multiplying a speed by a small amount of time, that's going to be a small amount of distance traveled. We need the small amount of time because a frame's gonna be rendered in a small amount of time. So in between the new frame and the old, we need to move a small amount of distance. So now our fireball should be able to move forward. Are we quite done yet? No. Actually, we need to keep this open. So now we need to determine whether our fireball had hit the player. So we're gonna use something called a trigger. Private void on trigger enter. And then it's going to have a parameter called other, and it's of type collider. What I'm going to do is this. On trigger enter, determine whether the object you had collided with was the player. If it was the player, say that you had hit the player. Otherwise, and if you just collide with anything else, destroy the fireball. So, player character, player, equals other.get component, and then in angle brackets, player character. If player does not equal null, that means we hit the player. So we're just gonna say in code debug.log player hit. And and then destroy game object. The textbook will say destroy this.game object. It's just that the this keyword, at least in Visual Studio, this might also be the case for your code editor. It might not be, but I'm just gonna say destroy game object. So it's going to destroy the game object for which this fireball script is associated with. So now I should have now the fireball script attached to the fireball prefab. We're not done yet, still. So, see this sphere collider component in the inspector? So I have the fireball prefab opened up. I need to set that to be a trigger. Is trigger, check that to true. We're not done yet. We need to now attach to this fireball prefab another component. So add component, click the add component and look for rigid body. Type in rigid body, select that, and then use gravity, set that to false. So this way, for triggers to work, they need to be rigid bodies. But now, since it's a trigger, if it moves forward and it hits something, it's going to invoke onTriggerEnter, and it's going to do that code where it's going to determine whether it hit the player, and regardless of whether it had hit the player, it's going to destroy itself. So the fireball is going to spawn in from the enemy, it's going to move forward, hit something, and then disappear. If it hit the player, it's going to say, hey, I hit the player. So now, if we play this game, let's see what happens. Hit me. You saw that, right? Hit me. Hit me. So now the enemy can fire fireballs at the player. Watch your step. And if you look in the console, it says that we've hit the player. It says we hit the player about 5 times now. So that works. We're just a few little tweaks away from calling the game functionally complete. So now the fireball had a field called damage. You saw that, right? I think it's fair to say that these fireballs should deal damage to the player. So let's do that by opening up these. Let's open up the player character script, and we're gonna add in a system where the player can take damage. So the code we add in is this. I'm going to add in a private field called health. So it's private int health. And in the start method, I'm just going to set that to 5 health. You might want to code this differently, so it's instead, you could have serialized field private int maximum health, and then a public field for current health. In the start method, you would say current health equals max health. For now, I'm just going to say health equals 5. So the player only has 5 health. I'm going to create another method. I'm just going to flat out erase the update method. So I just need public void hurt. Who hurt you? The fireball did. So I'm going to say int damage, and then I'm going to say health minus equals damage. So we're going to decrement the player's health by how much damage we were dealt. And then I'm going to say debug.log, and I'm going to print this a slightly different way. So I'm going to preface the string with a $sign, and then I'm going to type in health : and then I'm gonna enclose in curly brackets the health variable itself. So this way we're gonna print out the health to the console. So, let's go back to that fireball script. So now we have this hurt method. I'm going to comment out this I'm gonna comment out this debug.log method here, and I'm instead gonna say player dot hurt damage. So now the fireball, if it hits the player, if it touches the player, it's going to deal damage to the player. 1 damage, and then it destroys itself. 1 damage to the player, and the fireball destroys itself. So, now, if we play this game, reload script assemblies. Oh! Oh! Oh, the misery. Does everyone want to be my enemy now? By the presence of the fireballs? It looks like it. So now our game is functionally complete, but there are quite a few things that are worth adding. So, if you look in the console, now my health is like negative 23. So that is something worth fixing. So one thing that we can do to the player is make it a finite state machine as well. So it could have its own alive and dead states. And if it's dead, then the player is not allowed to move anymore. We'd also then print a game over text to the console. And when we get to programming UIs, we can also have text on the screen that says game over. For now, let's also retaliate back at the cube. It's dead. One thing that's worth doing is this controller, the scene controller game object could spawn a maximum number of enemies, possibly in different locations, and if the player is successfully able to destroy each one without dying, then we can display a victory screen. We can, or for our purposes, we can just say, victory, you win, in the console. Because right now, we have a health counter and it doesn't do anything other than count down into negative values. I'm at negative 39 health, which in most video games does not make sense. You should be dead by now. Basically, at this point, you should be dead by now. It should be game over already. So, oh yeah, there's also the issue of I can shoot the enemy repeatedly, and this happens. That's also something we need to fix. Oh yeah, also the spawn camping. So, these are some additions that are worth adding to your code, but a lot of what we can do from here is already here. It's just a matter of figuring out how to code that in. So, we could have a means of counting how many enemies were destroyed. We can have a means of determining whether the player is already dead and cannot move anymore. We can have the scene controller spawn enemies at random locations. We can have the scene controller spawn multiple enemies at once. So not just one at a time, but multiple at a time. So yeah. One other technical thing that I want to bring up. We are creating and destroying the same game object over and over and over again. That turns out to be taxing on the system because the process of creating and destroying a game object, it turns out to be a fairly expensive operation, especially if you're doing that for a lot of game objects. For this small quantity of game objects, it's probably okay. But if you're going to be spawning hundreds of the same game object, then you're going to want to consider something called object pooling. So I've left a few links in the PowerPoint slides discussing on what object pooling is. But if you want a summary, instead of creating and destroying game objects on demand, all you gotta do is create a few hundred at the start of the game, make them all inactive. If we need to create a game object, we don't create it. We just take one from the pool, activate it. And then, if it's no longer needed, say it's dead, we deactivate it, put it back in the pool. So for example, if I want to have a train with like 50 cars attached to it, choo-choo, I could just instantiate one instance of the same car over and over and over again. If this is the kind of train where we have to couple more cars as the game progresses, we might not want to spawn them on demand, but rather have a hidden area in the game where all these train cars are just hidden, and as needed, we take them out and add them to the train. So yeah, that is one application of object pooling. There are plenty more applications. So if you want a bullet hell game, you might want to have somewhere in the game where you have your object pool and it's all projectiles. You would then activate all these projectiles as needed. They would go forward. You might have code that despawns them after they've hit a certain distance. At that point, or if they hit something, they go back in the pool. So that is object pooling. So that is a more technical thing that we can do to our video games to make them a bit more friendly in terms of resource use. But for this basic game, even for this basic game where we can go forward in a lot of different directions, it's worth keeping in mind. So that's going to be it for chapter 3. I think what we'll be doing next is looking at game assets, but maybe before that we'll have to start getting into groups, because one project you'll be doing for your midterm project will be expanding upon. You'll be building upon this game with a team, or you can work on a different game as described in the textbook. So we'll be moving forward with more Unity concepts after this. It says that the next one is chapter 4, and that is all about game assets. Alright, so follow through this video. Ask questions. I would encourage you to ask questions if you're stuck on anything. I'll help out as needed, and then once we have a fully functional game, then we can think about what to do to add on to this. Maybe you don't want walls, maybe you want obstacles, maybe you want a pile of cars, and you have these agents just wandering around trying to shoot you down. Anyway, so that's going to be it for chapter 3. We got quite a few concepts already that we can then go with and go forward in our own direction. Even with this, we can go in all sorts of directions. Alright. Follow along with the video and we'll continue on from there. Alright, thank you, class.